Alright, here comes some without a calculator problems, and they're actually pretty easy and straightforward if you know what you're doing. If you have log base of 9 of something and you're trying to evaluate without a calculator, what you really want is for this to be log with the base of 9 of 9 to some power. So how can we rewrite 1 over 81 as power? Well, we can write 81 as 9 squared, and then we can move 9 squared up to the top, making it 9 to the negative 2. Okay, so that puts a negative 2 up here. Because these 9s are next to each other, this goes away, and our answer is simply negative 2. For natural log, that's log with a base of e, remember, so we want to write this as the natural log of e to some power, so that the ln and the e will cancel out, like what happened up here. So how do I write 1 over the square root of e to the 9th as e to some power? Well, it takes a couple steps. For one thing, the square root of something you can rewrite as the 1/2 power. Since it already has a 9, you multiply those together. So this is e to the 9/2. And if you move that up to the top, that's e to the negative 9/2. So that's what would go in this blank here. So our answer, once that cancels out, is just negative 9/2. Could it get any easier? It certainly does on 14 and 15. Since the 4s are next to each other, the log goes away, and your answer is simply the exponent. E to the ln, since those are next to each other and e and ln go together, they cancel each other out, and it equals 9. 16 and 17, we would pull out our calculator and simply type these in with 3 decimal places. The first one is 1.6902. The second one should give you an error because we would say that this is undefined. There is no log of anything less than 0. So it's undefined. Describe how to transform the graph of the basic function g of x into the graph of the given function f of x. So the negative in front of x reflects over the y-axis. This is where we have to remember our transformation rules. The plus 4 outside of our parentheses shifts up 2. Now on 19, I didn't really leave myself a lot of room to write all this stuff out, so I guess I'll just have to do my best. Graph the function, analyze it for all that stuff. Keep in mind log of x minus 4 is a logarithm shifted right 4, and so it will, instead of having a point at 1, 0 like it normally does, that'll be 5, 0. It's where it crosses, and so that means its asymptote, its vertical asymptote, would be at 4. And remember that your calculator makes it look like it stops, but that actually keeps getting closer and closer and closer to that vertical asymptote. It doesn't stop like your calculator probably shows you. So the domain. We only have x values to the right of 4, so that's 4 to infinity. The range, we can plug in values, or we can get values down here, way down here, all the way up as high as we want to go, so this is negative infinity to infinity. It is continuous on its domain, which is from 4 to infinity. It is increasing the whole time, so increasing from 4 to infinity. It does not have any symmetry. It is not bounded. No extrema. Vertical asymptote at x equals 4. And now with the end behavior, if you think about it, as we go towards negative infinity, we get stuck. We can't actually go to negative infinity on this graph because of what our domain is. So we really only need to look at, as we go to positive infinity, what's happening. And as we go towards positive infinity, it'll take us a while, but eventually we'd get to positive infinity.